All right, digital detectives, let's get right to it. We're about to open the case file on Chapter 3 of your CompTIA Network Plus guide. Think of this as your first briefing before you dive deep into the investigation. We're talking about the world of network addressing, which is, and I mean this, the absolute bedrock of all connectivity.
So, let's start with this question right here. Why can't I connect? This is it. This is the #1 mystery you will be hired to solve in pretty much any IT role you can imagine, from your first day on the help desk all the way up to network architect. For user, it's just pure frustration. But for you, it's a puzzle, and you're about to learn how to solve it.
You see, the real mystery is this. How in the world do billions of devices, services, and users actually find each other across this huge, kind of chaotic digital landscape? I mean, how does your laptop find one specific server in a data center thousands of miles away? Or heck, how does your phone find the Wi-Fi printer that's just in the next room? Without a system, it would be total chaos. And this is the key to the whole thing. The system that makes it all work is network addressing. Every single packet of data, every request for a connection, it's telling a story. And the language of that story is the address. Chapter 3 is all about teaching you how to read and speak that language fluently. It's what turns you from just a user into a network detective. Now, to solve this big connectivity mystery, you have to understand one critical fact. It's not just one address we're talking about. Nope. Digital communication relies on 4 different types of addresses, and they all work together in layers to get data from point A to point B. You know, the best analogy for this, hands down, is just sending a letter through the mail. Think about it. You wouldn't just write John Smith on an envelope and expect it to get there, would you? Of course not. You need a street address, a city, a postal code, maybe even an apartment number to be really specific about where it's going. Well, networking is exactly the same. So here's how those 4 addresses stack up. It's a logical progression. First, we have to identify the specific piece of hardware, and we do that with its unique MAC address. Then we need to find its location on a network, and that's the job of the IP address. After that, we need to target the right application on that device, which is where the port number comes in. And finally, we humans kick the whole process off using an easy-to-remember domain name. Okay, let's break that down. We'll start with the MAC address. Think of this as the permanent, unchangeable serial number for your device's network card. It's literally burned into the hardware at the factory. It's a 48-bit address, and it is globally unique. So no matter where you take your laptop or what network you connect to, that MAC address is always the same. It is the device at the hardware level. But a serial number doesn't tell you where a device is, right? That's what the IP address is for. It's a logical address. So, if the MAC address is your laptop's serial number, the IP address is its current street address. When you take your laptop from your home to the campus library, your MAC address stays the same, but you get a brand new IP address. It tells the network where to find you right now. So, we found the right device on the right network. But what do we actually want to do? Your computer could be running a web browser, an email client, and a game all at the same time. The port number is how the data knows which of those applications to talk to. It's the "to John Smith" on the envelope. Secure web traffic, for example, is always heading to port 443. That's how the message gets to the right person inside the house. And finally, we get to the human-friendly part. We don't type a long string of numbers into our browser. We type tarleton.edu. This name is a fully qualified domain name, or FQDN. Really, it's just an easy-to-remember alias for a numeric IP address. And the magic that translates that name into a number? That's a process called name resolution, and it's a huge topic you'll explore in this chapter. Okay, so now we know the 4 key pieces of evidence we're looking for: the MAC, IP, port, and domain name. But how do we actually find them and inspect them when a connection goes wrong? Well, that's where our investigator's toolkit comes in. Knowing the theory is great, but a good detective needs tools to work the case. This here is your starting toolkit. You'll almost always start with ping. It's your first question. Hey, are you there? It just sends a tiny packet to a target and waits for a reply. If that fails, you'll probably check your own settings with ipconfig on Windows or ifconfig on Linux. That's you asking, okay, who am I and what are my addresses? And if you think it's a naming problem, nslookup is your go-to for asking, does this domain name actually point to the right IP address? These are your tools for gathering clues. So why does all of this really matter? I mean, beyond getting a good grade or passing your Network Plus certification. It matters because this knowledge isn't just academic. This is your direct bridge from the classroom to your career in IT.
This right here isn't some problem from a textbook. This is a real ticket that an entry-level help desk technician will probably solve multiple times before lunch. A user has a problem, and you, with your understanding of addressing and your toolkit, have a structured, methodical way to solve it. This is literally what you will be doing on day one of your first IT job.
So let's be really clear. This chapter isn't about memorizing a bunch of facts for an exam. It's about building the core skill that gets you hired. When a hiring manager asks you to walk them through how you troubleshoot a connectivity problem, your answer is going to come directly from the principles you're about to learn right here. Okay, so as you crack open this chapter and start your deep dive, I want you to treat it like a case file. You're not just reading passively, you're actively hunting for specific clues and pieces of evidence that are critical to your investigation. Here are your primary targets for this investigation. First, you need to absolutely master the difference between a physical MAC address and a logical IP address. Then, really understand DHCP. That's the protocol that automatically hands out most IP addresses. Pay super close attention to the structure of IPv4 and why we're moving to the massive address space of IPv6. Get a handle on the role of DNS, the phone book for the entire internet. And finally, know when you should use a fixed, static address versus a dynamic one. This is your roadmap. Let's just zoom out one last time, because it's so important to see that this chapter isn't just another topic. Network addressing is the absolute non-negotiable foundation for everything, and I mean everything that comes next in your IT education and your career. And this really says it all. Are you interested in cybersecurity? You can't build a firewall or trace an attack if you haven't mastered IP addresses and ports. What about cloud computing? That's all about managing virtual networks and dynamic addressing on a massive scale. Network architecture? It all starts right here. You master this, and you have built the ground floor for any advanced IT career you want to chase. So, as you read Chapter 3, remember, you're not just learning technical details. You are learning the fundamental rules of how everything in the digital world connects. So the real question to ask yourself is this. Once you understand how it all works, what new systems are you going to build? What innovations will you make possible? And maybe most importantly, how are you going to use this knowledge to protect it all? Good luck with the chapter.